So, what we're going to talk about this unit is permutations and combinations. You're not going to know which one is which until we get through them. So at first, you just have to know that permutations, order matters. So a permutation would be like, if I asked you how many license plates you could make. Well, does the order matter in which you put the letters and the numbers to make a license plate? Or can you just willy-nilly just put like some numbers and some letters? No, you can't. You have to go letter, 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 number, number, number. Back off. Stay a while, you know?
I'll get there.
Okay. Phone numbers. Does the order matter? Or can you just put them in a random order and you'll get the same phone call? Order matters. What about pins for like to get into your car? Like, does the order matter? Yeah. What about codes to get into your house? Yes. All of those order matters. You know what code, not a key. Pay attention. Take back off. It's bothering me. I don't know why you're sitting using it as like a backrest. Rebel without a cause. Okay. So, we're first going to talk about the fundamental counting principle and some tree diagrams. So here, curriculum outcome we're doing is solve problems involving the fundamental counting principle. The fundamental counting principle is a principle that if we have certain amounts of this object, certain amounts of this object, certain amounts of this object, and I have to take one of each, I can find out how many total objects I can make. So an example would be, London is shopping for a sports utility vehicle. That's my daughter. She's shopping for an SUV at 9. You know, why not? The dealer says that she, not he, she's my daughter, she has 3 different models. Oh no, the dealer has he. Oh my gosh, I'm so struggling. The dealer can be a he. The dealer says that he has 3 different models. So, Bronco, Explorer, and Expedition, and that each model is available in 5 different colors: gray, brown, white, black, and blue. So we're going to complete a tree diagram to determine how many different choices London has. So, tree diagrams actually are more like anti-gravity tree diagrams, so it's not going to look like a tree going down like this, which is what you guys are going to try and do even after I explain this and you go to your assignment. You're going to try and do them vertically. It's not going to work, and you're going to call me over, and I'm going to say, remember when I said? This is how it's going to go. So we don't want that, so we're going to pay attention. So when we do tree diagrams, they're actually trees that go out this way, okay? So we're going to have our model, whatever option we have, we write model, and then we're going to put the models down with some spaces because each of those models is going to have tree branches off of it. So our models are Bronco, Explorer, Expedition. So we have spaces for a reason. If you write them side by side, you're going to be erasing them. So do as I do. Bronco, Explorer, and Expedition. So what we do is we run Bronco, Explorer, Expedition along the side, right? Those are the model options. And then our next option is color. Okay? So off of each of these model options, I am going to have 5 branches because there are 5 different colors. There's gray, brown, white, black, and blue. Gray, brown, white, black, blue. If you didn't leave this space, you're squishing. Okay? So I could have a Bronco in gray, a Bronco in brown, a Bronco in white, a Bronco in black, Bronco in blue, or Explorer in gray, Explorer in brown. And we have to be able to do tree diagrams in 30-2 because when we get to probability, we have to state outcomes. So we have to practice tree diagrams too. Brown, white, black, blue. Then gray, brown, white, black, blue.
Which one are you getting?
Pardon? She's a little young, so we're going to wait. See, you know? I had an Explorer. I hated my Explorers. Yeah. Also, she's probably getting none of these. She's probably getting like a 2001 Sunfire.
Sundowns, how about that?
Is there such a thing?
They're not in 2000, so.
Oh, they're earlier? Okay. So here it says outcomes. So you can list the different outcomes if you'd like, or we can just discuss them so we don't have to list them all, right? So we have a Bronco in gray, a Bronco in brown, a Bronco in white, a Bronco in black, a Bronco in blue, even though I just blue. An Explorer in gray, brown, white, black, and then blue. And then I have an Expedition in gray, brown, white, black, blue, because you're going to get someone in Expedition who's 16. Yeah, no, you're not spending money on it. No, you're not. Nope. So how many different outcomes do we have here? We have 15. London, 15 choices. That's really good English. London has 15 choices. Could choose from 15 choices. So many more options than London, 15 choices, which sounds fair. You choose. So here it says, look at the number of choices there are for the model and the number of choices there are for the color. How do you use these numbers to arrive at answer A without having to draw out the whole tree?
5 times 3.
5 times 3. So this is how we're going to use the fundamental counting principle. So this would be model. Now guys, I'm going to be straight up with you. This unit in high school I stunk at. Why? Didn't really understand the difference between a permanent comp. That would be 1. 2, well, I was too cool to ask questions because I didn't want the teacher to think I was stupid. 3, didn't go in when I was a lost soul. I just wung it. 4, I hated word problems. So I was like, I'm not paying attention because I don't like word problems and these will just pass. Except it's a whole unit and most of 30-2 is word problems. So as you've seen, the whole first unit was word problems. This whole unit is going to be word problems. And the next unit is actually exponentials with some word problems in it. Polynomials has half word problems. Exponentials and logs are half word problems. Sinusoidal has ends in word problems. And then probabilities all word problems. So don't be stupid Crystal Wagner, who was in high school and she's like, it'll be fine. It's just one unit. Don't do that. It's stupid. So it's my goal to have you not feel like I did. And if you do not struggle, just ask a question, okay? But the fundamental counting principle, what it says is you put the different types of things that we can choose from. So we can choose a model and we can choose a color. Those are our options. We agree? What little Crystal didn't understand is that the reason when you put a blank, you're putting a blank, that means you're choosing one of that type. So this means model is what I write under here. This means I'm choosing one model. That's what this blank is. If I had to choose 2 models, I couldn't do this. I would not be able to put a blank. Okay? This means I'm choosing one model and one color. We agree? The other thing we need to know, and I'm going to write this, and I would write this in your notes too. Remember, you have an open book and then a closed book, so you get your open book first. And if I use the word and, I multiply. If I use the word or, I will add. Now the easiest way to remember this is and add. They look very similar, right? They look like they're basically the same word, just a different letter. Well, and add are so similar they hate each other. So and does not go with add. And is multiply or you add. They do not go together. Okay? So do I need a model and a color to pick the vehicle? Or could I just have a model or a color? Could I just walk off with blue? I'm just going to buy the blue. No. You're going to buy the Bronco that is in blue, right? So we need model and color, which is why we're multiplying. Because we need the model and the color, right? The word and is in there. So you have to show that dot because that dot means multiplication. Now, this is where I was lost. Like a little lost soul. Didn't understand it at all. So this means I'm picking one model, I'm picking one color. I was lost there. Then I was super lost. Because above it, I thought I thought that's what I was choosing. No. Above it is how many options I have. How many am I choosing at a time? I'm choosing one model and one color. That's what the blank means. I'm choosing one of each. Above the line, I list how many I'm choosing. So, how many models are there?
3.
There are 3. I'm choosing 1. How many colors are there? 5. I'm choosing 1. That's what the blank means. So I have 15. So that's how they arrived at it. You have to understand that every blank I'm choosing 1 in, and then above it is how many options there are, not what option I'm choosing. Okay? So here, the dealer tells London that each of the SUVs comes in 2 editions, SE and LE. How many different choices does she have now? So she's still choosing 1 model. From how many models? 3. She is choosing how many colors? She's choosing 1 color, but from how many colors? 5. Now she has to choose an edition. Leather model, standard edition, leather edition, I think is what those are. She has to choose an edition. She is choosing 1 edition. She's not allowed to have both editions. She has to choose 1. From how many?
2.
So now how many options does she have? 30, which makes sense because she had 15 previous to being able to now have 2 options for each of those 15. Right? And we're going to flip over. Okay. The fundamental counting principle can be extended to more than 2 tasks. If one task can be formed in A ways, and another task can be formed in B ways, and another task in C ways, and so on, then you can multiply them. The catch is, though, that you can only pick 1 of each task. So, for example, everyone's paying attention to me? If I was making a menu with an appetizer, a main course, and a dessert, okay? Everyone's listening. So for my appetizers, I have 3 options. For my main course, I have 3 options. For my dessert, I have 4 options. Okay? If I only choose 1 appetizer, I would have 1 blank. 1 main course, I would have 1 blank. 1 dessert, I would have 1 blank, right? And then I would go 3 times 3 times 4, because I had 3 options, 3 options, 4 options, right? But each of those blanks represents 1. If, however, I could choose 2 appetizers, 1 main course, 1 dessert, I can't use the fundamental counting principle anymore. The fundamental counting principle only works if I choose 1 from each part. If I have to choose 2 appetizers, I'm done. I can't use the fundamental counting principle. I have to do a different method, which we learn later. Okay? So I can only choose 1, because that's where that blank comes in. 1 model, 1 color, 1 edition. If I could pick 1 model, 2 colors, like make it a 2-colored car, and 1 edition, I can't do the blanks anymore. I have to do it a totally different way. Okay? So let's look here. Your turn. A toy manufacturer makes a robot in 3 parts. Part 1 is the head, and it may be colored red or blue. Part 2 is the body, may be colored orange, white, or black. Part 3 are the shoes. They may be purple or pink. Determine how many different colored robots can be produced using a tree diagram. So I am picking 1. I'm going to tell you this. You can have 1 of part 1, 1 of part 2, 1 part 3. So try out the tree diagram, remembering that you'd put part 1 on the top, then part 2 beside it, then part 3, and you list your stuff below with branches heading to the right. Okay? So part 1, I'll start you off. I would write part 1 up here. And what options do I have? Red or blue? Do I put them right side by side? No, because I'm going to get 3 arrows off of it for part 2. So I go red and then blue. Then up here I have part 2 now. And part 2 can be orange, white, or black. You try and finish the tree diagram. Part 2 can be orange, white, black. For this one, it can be orange, white, or black. If there was only 2 parts, this would be 6 different toys that I could make, right? 6 different outcomes. But there's a third part that can be purple or pink. So each of these has a purple and a pink offset. How many different options do we actually get? 12. Now it says up here to do the fundamental counting principle way. So we have 3 parts, correct? And we're choosing one of each part, yes? So, first part is part 1. And below it, I can list my options. My options are red or blue. How many options is that? How many options is that? 2. So I am choosing one option out of 2. That's what that means, right? Then I have part 2, which has orange, white, black. Now I still have one option. I'm choosing one option out of 3. Then I have part 3. I'm choosing one option out of purple and pink. The blank means one option. The top means how many options there are. Now I have to decide, do I need part 1 and part 2 and part 3 to make the toy? Or could I just have part 1 or just have part 2 or just have part 3? I need each of the parts, right? So I need part 1 and part 2 and part 3. So what operation am I going to do? Because I'm using the word and. Multiply. Because and add don't go together. And what do I get here? 12, which is the exact same number of options as my tree diagram. Look, we have another one. Try it out. I did one, we did one, you do one. Okay, so we have jersey along the top, and we have red, black. Then we have the pants, which are white, red, or black. Most people did this good. This is the last one that you guys kind of lump them together, which you can't do. So white, red, black. And then there's just socks in red. So you would go socks. So a lot of you just wrote the one word red and put arrows. You have to go like this. 1 arrow off, red. 1 arrow off, red.
Would there be anything wrong if I put socks in front of jersey, just so I could write red only once? You're still getting 6 options wrong.
Not really, but not wrong, but yeah.
Do you prefer if I did that?
Yeah. It doesn't count. Okay, so how many different outcomes did we come up with? It was still only 6, right? Because you still have 6, all different ones. How can we prove this to the fundamental counting principle? Well, we choose one jersey out of how many? 2. So the 2 goes above because that's how many I'm picking. And, so multiply. I need pants. How many? How many different pants? 3. And I need what? Socks. The catch is 1. So I still have only 6 different outfits. Anyone know what a color rush is? Well, I guess I told you. Shouldn't have. I just ruined it.
Just like the same color.
Yeah, their whole, if you see them, they do it in football and baseball. They color rush them. So like every single thing that they have is the exact same color. Sometimes their color rush color is like the teeniest, tiniest color in their jersey, and then they color rush themselves in that color. So some are really cool, like the baby blue ones, and then some are not nearly as cool. But it's just fun facts, you know? So what is the probability of wearing a color rush outfit out of here? So when we do probability, which is our very last unit, this is just extending just to show you why we need like the tree diagram. It's kind of like a selling feature to you. This is why we're drawing the tree diagram, and why can I just do that? Because when we hit probability, we need the tree diagrams. This is me like selling it to you for the last unit. So we want probability, and if I say color rush, that means I want the probability of red, and red, and red, and red, right? From all three of them. So I just want all three red, right? So we know that probability is always over total. Every time you do probability, even since you're little, it's always over the total. That never changes. So how many total options do I have? 6. How many of them are color rushed? 1. It's just this one here. So when you actually draw these out, you see the total because you can count the total, right? And then you can literally circle the ones that fit what they're asking me for. They're asking me for a red jersey, red pants, red socks. So there's only one option that gets me that. So it'd be 1 out of 6. Okay? Flipping over or just looking at your next page if you have them in a binder. So here's some practice. We're just practice the whole time. A lot of these you just need more practice, more practice, more practice. Now, keeping in mind, everyone looking at me, put your pencils down because I need you to really understand me. 30-2 is often math panicked people, okay? Somewhere along the line you thought you sucked at math, and therefore you have this math negativity. I would say that's about 85% of you. That's usually how it works. Okay? You can be the 15%. That's totally fine. So, why, when you have that, what happens in class? I get through 2 examples, and you want to immediately be able to answer every single example in the world, but I'm still going through notes. So should you be able to answer all of the questions when I haven't even gone through how to do all the questions? No. So should you have sheer panic when you see a question and don't know how to do it when it's in the notes and not in your homework? No. You're learning how to do the question, right? Should you also have sheer panic if you can't do the question right now? You go home and you do the homework and you can't do the question. Should that cause you sheer panic? No. You don't have a test tomorrow. Should, when you're writing the test, you completely can't answer any questions, should that create sheer panic? Yes, that's the moment you can have sheer panic, right then and there. In the midst of your test when you're lost, there's the only place that I will allow you to have a little bit of sheer panic. Shake it off, try again. You know, like that's fine. But that's the place where the panic should occur if you don't know how to do that. Up until then, you shouldn't panic. I go home, I don't know how to do the questions, I'm having a little bit of a panic about it. Cool. Guess what? I have a teacher who's here at lunch and at nighttime who can answer any question. Don't panic. I just come and I ask you how to do the questions. I don't know how to do these questions. I don't know how to do this lesson. Cool. You come in and you say, I don't know how to do this lesson. And I throw 800 questions on the board till you can do all the questions. Okay? So panic shouldn't happen. And you are better at math than you think if you're one of those 80% of the people who think you aren't good at math. You are. Trust me. Good marks happen in 30-2. Okay? So if on a test you don't know what you're doing and you're completely lost, that is the only place where I think a panic should be appropriate. Okay? A little anxiety here or there. That's okay. You can come around your anxiety. But panic should only happen if you are completely lost. And if you panic on a test, material falls out, right? Like panic takes place and then you just can't think of stuff. So panic actually is the worst thing you can do on a test. Can't do one question, move on to the next one. Come back to it. No big deal, right? Don't freak out about that one question. It's one question. You probably can do the rest. Okay? So we're trying to decrease the panic when you get to these questions and you don't know how to do them. Okay? And I'm trying to sell, if you're a little lost, it doesn't matter. Come in and ask questions. I will help you. So you're not lost. Okay? Cool. So Jeremy, I really did a great job with these notes. I put my family in it. That's my brother. You're welcome. I have London, my daughter. I didn't realize I did this. I bet you there's some. Still no one. Let's see if there's anyone else in here. Oh, Sally. She ain't part of my family. I don't know who Sally is. Get out of my life, Sally. That's what I think. Okay, we're going to go back to Jeremy. He's a great guy. I like him. He's my brother. Should like him, you know. Jeremy wants to go shopping for pants to make sure he had enough different outfits. You know, an outfit must have a shirt, a pair of pants, and a pair of socks. Can I use the fundamental counting principle if I'm choosing one shirt, one pants, one pair of socks? Yes. If the person could pick 2 pairs of socks because it was really cold outside, could I then use the fundamental counting principle? No. I have a new method. You don't know how to do it. Obviously, I'm not going to ask that question today. I'm going to ask it when we get to that point, right? So, he wants a shirt, one shirt. He wants 1 pair of pants. That line means I'm choosing 1. He wants 1 pair of socks. Now we have to decide, does he need a shirt and a pair of pants and socks? Or could he have a shirt or a pair of pants or socks? If you say or, he could be standing in just socks. That's creepy. So it's not or, it is and. Okay, I'm going to text my brother and tell him I talked about him wearing only socks. Creepy, right? And. So, that is not an outfit. They said he needed, up there it says, shirt, pair of pants, and a pair of socks. Like it's literally written in the question, right? So I need and. I need to multiply. Okay. To not repeat the same outfit for 48 days. He's going to have to wear like some of the same clothes, right? But he doesn't want to wear the same outfit for 48 days because he is challenged to do this. And he is like, I am not going to, you know? Yeah. Okay, so we're going to need to equal 48 outfits. They gave us the total this time, didn't they? So now it says, in his closet, he has 8 different shirts, 2 pairs of different socks. Well, that is a low amount of socks. Maybe you have only 2. How many? That'd be so much easier to wash, though. And you probably wouldn't lose the other pair, you know, if you only had 2. That'd be probably much better. How many different pairs of pants must he buy? So we go here, we go to shirts. I'm choosing 1 shirt. From how many shirts? The 8 goes above, right? Okay, I go to pants. How many different pants does he have? I'm choosing 1 pair. We don't know. And what do we, when we don't know a known, in math, what do we put? X. Let me say question mark. We're going to use a variable. That's okay, question mark would work. And socks. Okay, he needs to pick 1 pair of socks out of how many socks? 2. Now, some people could say, well, I know it's 3 because 16 and 48, I have times by 3 to get 48. Cool. Or we could mathematically do it. So 8 times x times 2 is 16x equals 48. And then we just divide by 16. So what does x equal? 3. So if you had to actually show it in a written response, this is what you'd want to do. If it's a numeric response, you could say, okay, well, I need a 3 to make me 48. When we fill a numeric response, we always go left to right. Okay? Do all of the boxes need to be filled in? No. And the decimal points only exist in the 2 middle boxes. So if your answer was like 0.1, you can't go decimal 1. There is no decimal bubble for the first box. So you have to go 0.1. Okay? And you're like, if there's no decimal bubble, I just won't bubble it. Cool. The machine counts your bubbles. That's all it does. It's like very last resort, they'll go and look if a bubble like came through. Like sometimes you'll bubble too dark and then you erase it and you bubble a new bubble. The machine might throw an error code out. That's the only time they look at your numbers. So you have to bubble properly. If you're putting decimal 1 but you don't actually bubble a decimal, is the machine reading decimal? No, there's no decimal, right? So you have to hold a dot for each one. Okay. Next one here says a math quiz consists of 6 multiple choice questions. So how many parts are there to this test? 6. 6 multiple choice questions. Okay? So how many blanks are we going to have? 6. We're going to have question number 1. Question number 2. Question number 3. Question number 4. Question number 5. Question number 6. When I draw the blank, that means I'm picking one answer, which is true. When you pick a multiple choice question and there's an answer to it, it's one of them. It's A, B, C, or D, right? You have one answer. So I'm choosing one answer for 1 and one answer for 2, 1 for 3, 1 for 4, 1 for 5, 1 for 6. Now, how does the test work? Can I choose to do number 1 or number 2 or number 3 or 4 or 5 or 6, or do I have to do number 1 and number 2 and number 3 and number 4 and number 5 and number 6? I have to do all, right? It's not an optional test type question. So because I have to do all of them, I'm going to multiply. Because I need this one and this one and this one and this one and this one. Now here it says a math quiz consists of 6 multiple choice questions. Cool, I got my 6 multiple choice questions down. Each question has 4 choices, A, B, C, or D. But I'm only choosing one to be correct, right? How many different answer sets are possible? So I'm choosing one out of how many options? 4. Then I'm choosing one out of 4, then one out of 4, and then one out of 4, and then one out of 4, and then one out of 4. Some people tell me that's 4 times 6. That is not. That is 4 to the power of 6. Do you believe it's 4,096? So for those of you with a little measly 6-question quiz and you think you're going to guess the right answers, there are 4,096 different answer keys that can come out of those 6 questions with just A, B, C, or D. Because you could have A, right? B, 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 A, B, 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 A, B, 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 B. You know what I mean? So you have a 1 in 4,096 chance of guessing the correct answers on a 6-question multiple choice quiz. Yeah. What do you learn from that? Study. That's what you learn. Okay. Side note, how can I change this question? Still, 6-question quiz. Everyone's listening? Still giving you a 6-question quiz. Still has the answers A, B, C, D as options. Okay? So, this is what it is. Mrs. Lepp is making has a 6-question answer sheet. Okay? So I have a 6-question answer sheet. This is my answer sheet. She has the answers. It's an answer sheet. B, C, A, D, B, B. Cool. Right? That's her answer sheet. She's holding a coffee in her hand, and she foolishly trips, and she pours the coffee on the answer sheet. And 3 to 6 get washed away. For effect. How many different answer keys can she have? Try it out. We still have 6 questions, so we still have 6 blanks. Let's see how we did. 1, 2, 1, 2, 3, 4, 5, 6. Okay? This means I choose 1. Oh, good, I have an eraser. Forgot about my effect that I was performing there. Okay. I have 1 I can pick out of how many? How many options do I have for number 1? 1. It is B. The only option I have is B. Okay, what about 2? How many options do I have? 1. It is C. What about this one? How many options do I have? 4. Next one? Which is 4 to the 4, which I don't know what that is. Yeah. You're right. Then we're flipping back to our notes. You're looking at your notes. I'm looking. Yep. Yep. All right. Okay, guys. Put your pencils down and look up here. We're all paying attention so I don't lose you. Okay. Go team. Ready? I am going to give you numbers, and you are going to tell me if they are odd or even. We start this in about grade 2 or 3, so I believe in you. Even if we didn't, I still believe in you. You guys are smart. Okay, ready? 12.
Even.
guys all were successful. 307.
Odd.
Make it harder. 20,562.
Even.
Okay, look at you guys, all rebels showing off. All right, okay. 6 billion.
Even.
I'm not done. But yes, okay. Let me go. 6,765,475,901.
Odd.
What are you only listening to?
The last.
The last digit. That is all you're listening to. And then I say, how do you tell if something's odd or even? And you say divisible by 2. That's what I get all the time. Cool. Not helpful in this instance. All that matters for odd numbers is it has to end in an odd number, right? Even numbers, the last digit needs to be even. That's what you're telling me. I could say like, 7 billion, I don't know what comes, and 4. And you're like, even. Yeah. You don't care what else I say before that. You only care about the last digit. We agree? So they're not going to be like, oh, I want to know how many 4-digit odd numbers there are. Remember that odd digit numbers means that it ends in an odd number. Like, they're not going to say that. You need to know that. Okay? So here it says, how many odd 4-digit numbers? So odd, if I see this, I say ends in an odd number. Like I help myself out. Okay, pencils back down. Brain matter needed. I'm going to give you a 4-digit number. You're going to tell me if I'm telling the truth or I'm a liar. Okay? 4,210. Yeah or no? Is that a 4-digit number? 4,210. 4-digit number. 4,210. Right?
Yeah.
Okay. 1,000. Is that a 4-digit number? 1000. Yeah. Okay. 970. 970. 3-digit number, right? Okay. I'm going to be so good. I'm going to pay you in a 4-digit number. Ready?
I want decimal.
I'm paying you with the decimal. Too cheap. Okay, ready? 4-digit number. 0007. You're welcome.
Decimal.
I don't want to pay you in a decimal. 0007. Did I pay you in a 4-digit number?
No.
What did I pay you in?
7.
I paid you 7. True.
Yeah, 7.
What did I pay you in a digit number? 1-digit number, right? So the key thing to a 4-digit number or any digit number is it can't start with what?
0.
It can't start with a 0. If it starts with a 0, it's actually a 3-digit number, right? If it starts with a whole bunch of zeros, well, it's terrible. That's what it is, right? So if I see this, if I say odd, it has to end in an odd number. And if I see a 4-digit number, 4-digit codes are different. Can a 4-digit code start with a 0? It could be a terrible code and everyone's breaking into your house. It could be 0000, right? Like, codes can start with whatever number they want to. But a 4-digit number means you cannot start with a 0. So can't start with 0. So, keeping in mind, every blank I draw can only contain one item. We agree? We've talked about that. Every blank I draw can only contain one item. I need 4 digits, so I'm going to have 4 digits. Here they are. Boom, 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 boom. And I need each one of them, so this one and this one and this one to make my 4-digit number. Everyone's following, right? Each of those blanks can only contain one thing. So that means 1 digit. Is 10 a 1-digit number? No, 10 is 2 1-digit numbers, 1 and 0, correct? So what are the 1-digit numbers I can choose from? 0 to 9, right? Those are the options I have. So whenever I do fundamental counting principle, I will list the number of options below. I'm only choosing one option, but the number I list above the blank is how many options I have, not what number I'm choosing, okay? I have to start with restrictions first. So I'm going to start with the very back number, because the very back number has to be what?
Even or odd.
Odd. So it has to be 1, 3, 5, 7, or 9. What about 11? 11 is 2 ones, right? 11 isn't 11. 11 is 2 ones. Because I have to have single digits in this blank, because I can only put 1 digit, right? So how many options do I have for that blank? I have 5. So I put a 5, I'm choosing one of these, and I put a 5 above. Oh, little Crystal Wagner, she thought I was choosing 5. Like when I was in high school, I was like, oh, they're choosing the number 5. No. That number up there, and half of you are probably thinking the same thing, so that's what I'm saying it. The number up there, that 5, doesn't mean I'm actually choosing the number 5, does it? It means I have 5 options, and they are 1, 3, 5, 7, 9. That's what that 5 means. That's how many options I have, okay? And I'm choosing one of them. It doesn't matter which one, because it'll make me an odd number, right? Okay, then I have to go to the first blank. And the reason why I have to do the last blank and the first blank is because the first blank can't be 0. So I have to always deal with my restricted blanks first. So it can't be the number 0, but it can be 1 to 9. Right? It can be the numbers 1 to 9. Just can't be the number 0. Or it would be a 3-digit number, not a 4-digit number. Everyone following? All right. How many options is that, 1 to 9? 9. So that's why I'm putting a 9 up here. Does that mean I picked the number 9? No, it means I chose 9 options. Everyone following? I literally in high school thought I chose number 9. Okay? We don't want you in the same boat. It's a bad boat to be in. It was a not good boat. Get out of my bad boat. Okay? The middle 2 blanks, is there any restrictions on the middle 2 blanks?
No.
So what numbers could they be?
0 to 9.
Yeah, they just need to be single digits. So 0 to 9 and 0 to 9. So then my teacher told me that we could only put single digits in the blanks, right? And then my teacher put a 10 up here, and my mind was blown. Because I was like, dude, that is a double-digit number, and you are a liar. That's what I was thinking. Except he wasn't. I just didn't get it. The number above the blank is not the number you're leaving there. We've discussed this, right? That's the total number of options we have. The number that I'm leaving here is either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Those are the options. These are the options that I can put in that blank, correct? The number above is just how many there are, which is 10 of them. It's not the number 10. Okay? And then this one has 10 again. So it's 4,500. On a separate sheet of paper or somewhere at even the top of that paper, I want you to do this one. Try this one out. How many odd 6-digit odds? Yep. Okay. Odd 6-digit numbers are there? Try it out. How many blanks do we have? How many blanks? 6. We still need all of them, so we're going to multiply. Check and see. Every single one you get off your phones. Check and see that you have dots in between each of your blanks. If you don't, you're not showing the operation of multiplication. So go back and make sure that you have the dots in between your blanks, or you won't get the marks. Now it says odd, so I know I need to end in 1, 3, 5, 7, or 9. 6 digits means this has to be a 1 to a 9, or it would be a possible 5-digit. So I go back here, I have 5 options, I'm choosing 1. Here I have 9 options, I'm choosing 1. And then the middle is all 0 to 9, right? So it's just going to add an extra 2 10s being multiplied. So you should have 450,000. Just adds 2 zeros to 50,000. The next question right below it asks for 4-digit odd numbers without repetition. So that means I can't have like 4441. Okay? I can't have any sort of repetition. It sounds a lot harder than it is, okay? I've come up with the method that is called the box and hold method. I made it up. You will find it nowhere. So what I do is I still do it in the same order. The catch is that if you can't repeat, you have to box and hold the number so that when you go to list your outcomes for the next blank, you don't use that number, or else you could possibly repeat, right? So still odd 4-digit numbers, but here's the no repetition. So I'm going to box and hold. So I still need my 4 blanks. 1, 2, 3, 4. I still need to start with the restrictions first. My restrictions are the back number has to be 1, 3, 5, 7, or 9, because it has to be odd. And the first one can't be a 0. Those are still the same case. Yep. Yep. So I'm going to start with the back one first. So I list my options. 1, 3, 5, 7, 9. So I still have 5 options, right? I'm going to put a 5 up here. But now I have to box and hold a number so that when I go to list my options for the first blank, I don't use one of the ones that I used. Okay? So I have the option 1, 3, 5, 7, or 9. I have to pretend to keep there. It doesn't matter which one. It's just that when you box it, you can't use it now in the first blank. So I'm going to use the 9 because I'm slightly lazy. And I want to use an arrow in between. So I'm going to pretend I'm holding the 9. If you pretended you held the 7, or you were pretending you held the 5, or the 3, or the 1, in the first blank now, you just wouldn't list that number. Because you're holding it. You can't repeat it. You're pretending you used it up. So we're not allowed to repeat. So now, I know I can't use a 0 in this blank. Right? I'm not allowed to use a 0. What else am I not allowed to use now? 9. Is it always going to be 9? No, if you chose 7, you can't choose 7. If you boxed and held 5, you can't use 5. If you boxed and held 3, you can't use 3. If you boxed and held 1, you can't use 1. So you just have to box and hold something. Okay? So I just picked out the 0 and the 9. So what's still left? 1 to 8, which is 8 options. Then what must I do? Choose another thing to box and hold. So I'm going to choose to box and hold the 8. And then here's where the problem happens. So people tell me it's 1 to 7. Someone just said it. Okay, she said 0 to 7. She's just not going to tell it, but I heard it. It's 0 to 7. Why is it not 1 to 7? Because now you can finally use 0 again, right? You couldn't use 0 at the back, it would have made it even. You couldn't use 0 at the front because it would have made it a 3-digit. So you have to remember to bring the 0 back for that second blank, and people do not, and they'll have the answer to you forgetting to bring it back. So they'll have the answer to 8765 when it's actually 8, 8. Then I hold 1, say I hold the 7. Then I have 0 to 6 here, which is 7. So 8 times 8 times 7 times 5. Remember, if this is written response, you have sentences. We're skipping example 4. We're going to go to example 5. The telephone numbers allocated to subscribers in a rural area consist of one of the following. They don't have to follow real telephone number rules. You have to be like, hey, this is in the world of Canada, and in the world of the Earth, this does not work here. This could be Mars. This could be completely made up. It doesn't matter. Okay? So it says the digit 345. So the digits 345 followed by any 3 further digits. So could we go 3, 4, 5 and say that's one option? Or if that's confusing to you, you could just go, okay, the digits 3, then 4, then 5. So the digits 3, 4, 5, followed by any 3 further digits. What does that mean, any 3 further digits? What options could it be? 0 to 9. Still single digits, can only fit in these blanks. And I need to multiply because I need all these numbers. Don't know why that blank's gone. Or What do I do when I use or? Ah, eraser. Good, it's still there. Or. What do I do when I use or? Add. Or means we add. So when we go between cases, we always add cases. We have the first case or the second case. We add our cases. So we're going to go or the digit 2 followed by one of the digits 1 to 5 followed by any 3 further digits. So what could these ones be? Okay, so we list our options below. We say we're putting one number in each of these. That's why we have a blank, right? Above the line, we list the number of what? Possible option, yep, possibilities. So, if my option is at number 3, what do I have above the blank? 1. If my option is the number 4, what do I have above? 5? 0 to 9? 0 to 9? 0 to 9. When I multiply those out, I get 1,000. Plus. Then we have the number 2, 1. Then 1 to 5, 5. Then 0 to 9, 10, 10, 10, which is 5,000. Which equals what? 6,000 different possibilities. Okay. Below we have the word English. If I have the word English, so this one says, consider the number of distinguishable. Distinguishable just means you can tell them apart. It's not like we're going to bring out the Scrabble book and see if they're real words, okay? Distinguishable 4-letter arrangements that can be formed from the word English. And now some people are like, well, I have an unlimited amount of letters. No, you have the word English, like on a Scrabble tile. So you have an E. Well, let me put it on this board. It freaks out on me. It used to do it, let me do it on the smart board, but it doesn't. You have an E. You have an N. You have one G. One L. So putting your pencils down, because I need to make sure everyone gets this. One L, one I, one S. Oh my goodness. Oh my goodness. S, and one H. Do I have any doubling or tripling letters here? Like 2 E's, like in leap? L-E-E, or peel? Okay. Everyone has their pencils down. Everyone is paying attention, right? I have all the attention here. So, can I repeat E's? Do I have an unlimited amount of E's? Do I have an unlimited amount of N's? No, I have one E, one N, one G, one L, one I, one S, one H, right? And every time I draw a blank, how many objects can I put in a blank? One object. So they want a 4-letter word, so I'm going to put 4 blanks. And don't draw any of this down, because I'm going to go back there and show it actually on the paper in a second. You're just putting your pencils down, and you're all just paying attention. Okay? Now, what do I do for the first blank? For the first blank, how many letter options do I have? How many are in English? 7. Now, what am I going to have to do? Leave a letter behind, am I not? If not, I'm never making a word. If I say I have 7 for the next blank, am I ever forming a word? Now I'm picking the G, and then I'm saying, psych, and I'm putting the G back. So I have 7 again. Then I'm picking a G, nah, and I'm putting the G back. Am I ever forming a word? No. So what I have to do is I'm going to, every single time it's a word, you have to treat it like you don't have repetition. That you have to use up a letter each time, right? It's a Scrabble tile. You have to literally give it to them or you're never making a word, right? So we're going to have to box and hold whenever it's a word. So for the first one, I'm going to pretend to put a G down here. Okay, I'm leaving a G. I'm boxing and holding a G. Could I have done any of the other ones instead? Yep. It doesn't matter, right? Because I'm trying to just make 4-letter words without any restrictions. Okay, how many options do I have now for the second blank? 6. Which letter do we want to pretend to leave there? I heard owl, and I was like, what? L. Yes, we have one of those. We do not have an owl. Okay, then how many letters do we have left? 5. Which one are we going to pick? And then 4, and then pretend we leave the I. It doesn't matter. So whenever I box and hold, I'll always have one word that I made up, which is, let's see, it's a great word. Everyone likes it. So what you have to remember, do you see I have letter tiles? That's all I have. I wasn't allowed to say, hey, I have 7 options for here and 7 options for here. I had to leave a letter behind because I don't have an unlimited amount of E's and N's and G's, right? So on here, pick your pencil up. It says any letter can be in any position, but it does say 4-letter arrangement. Sometimes we arrange all the letters in the word. Sometimes we arrange some of the letters in the word. All of the ones in this question are going to be 4-letter words. Okay? So it says any letter in any position. So that means no restrictions. So if I wanted to, I could actually show all my options below, correct? E-N-G-L-I-S-H. So instead of doing the papers, I could just show it down here, which means I have 7. And then I have to box and hold one, and I held the G, because that's what we decided to hold. So now for this next one, I have E-N-G, E-N-L-I-S-H, which is 6. Then we held the L. Then I have E-N-I-S-H, left. So that's 5. Then we held the S. Then I have E-N-I-H, which is 4, and then I pretended to hold the I, and that's how I got the word busy. So go 7 times 6 times 5 times 4 in your calculator. I think it's 840. Yeah. Because I did 42 times 20. So B has a restriction. It says the first letter must be E. The first letter must be E. So I fill my 4 blanks. I can have 1 letter here, 1 letter here, 1 letter here, 1 letter here. The first one has to be an E. Box and hold it. I just used up my E. How many E's are there? If there was 2, I would put a 2 there. But we're not dealing with repetition until later because we have to do something else if we have repetition. Is there any restrictions on the rest? No. So I could have N-G-L-I-S-H, which is 6. And then I have to do what? Box and hold 1. Then I have N-G-L-I-S, which is 5. And hold the S. Then I have N-G-L-I, which is 4. And now my pretend word, one of my pretend words I made up is S-C. I don't know. All right. C says the first and last letters must be vowels. Vowels are A, E, I, O, and U. No, sometimes Y's, because the Y's only come into effect when you don't have a vowel in the word, right? So they don't make us deal with that. Opposite of a vowel is a consonant. So there are 5 vowels and there are 21 consonants. That's the opposite of a vowel. So the first and last letter must be a vowel. How many vowels are in the word English? 2. So it doesn't matter if I start with the first or the last, but I do have to box and hold after whichever one I start. So I'm going to start with the first one. I have an E and an I. I put 2 here, and then I have to box and hold something, correct? I'm going to hold the I because it just felt like it. And then I have only the E for this one, which is 1. Cool. Boxed and held that. Then I have left for this one N-G-L-S-H, which is 5. Then I box and hold. So what I'm going to have for here? 4. And it's 40.